Hey guys, welcome to a new tutorial of mine. From my last videos, I designed a 3 GHz low noise amplifier, and for this video actually I designed a 2.4 GHz LNA, basically using the same configuration as I did from the last videos. And I'll show you the simulation results, and for those who are interested in the LNA design, and uh, also not just that, this video is mostly for getting the PCB manufactured. So, and basically the requirements that the PCB manufacturer requires, like what files they need and everything for their for them to be able to manufacture it for you. Because I've had many times where I've given them files and it failed, and they would not be able to see the simulation. But I'm going to go ahead and show you how to do that in a minute. I also want to let you know for the LNA design that for this LNA design that I'm getting manufactured, and I'll show you all the variables and everything I'm using for the design. In the next video, I'm going to test the design on a vector network analyzer and see how everything lined up. Hopefully it lines up okay, but it's the second time for me to work on this on my own design. So in future videos, I want to show you how to design power amplifier, mixer, oscillator, IF amplifier, and much more. I've had a lot of requests from other people, and it's something I've been interested in myself. So let's just go ahead and get started. I want the people that are here to see how I'm designing the LNA, and show you guys the simulation of my design. So first of all, let's go ahead and show you some simulation results. So here is my simulation for my S21 is 15.74 dB. S11 is negative 18.39, and S22 is negative 22.87 dB. So let me show you the design. And I'm using an ATF 55143 transistor. They're actually out of stock. They don't have it anymore, but you can buy them on eBay, or other people have them, so you can get them. And in here, from my other videos, I just included the pads, but I did include the pads here, so that when I get it manufactured, I know for sure that it's going to work the way I want it to. Alright, and you can see here I got like a lot of grounds here around the circuit, because that basically says that, you know, everything on this bottom part of the circuit is actually grounded. You can also simulate this without the bottom layer. and it's supposed to come out with a better simulation result, but I'm just gonna go ahead and do it the way that I was doing it before, and just I want to see the actual test results and see how what I did, and see the actual facts from it. So and you guys will see that too in my next video. So here we're going to get started on the actual design. Here I need to clear this because I'll show you this later. This is a website that you can use to test your files to make sure that all the files are working the way that the PCB manufacturer wants to see it. So so I'm using PCBWay. Let me go ahead and restart this real quick. Alright, I'm using them because they seem pretty cheap the way that to get it manufactured. There's a lot of other places that are like, very expensive. I don't understand why, but there is one thing that they do not include in their design. You can't use aluminum substrate, which is which would actually be better for a low noise amplifier, because it makes this it should help your signal quality and low losses in the circuit. So this is a good way to start for designing the PCB. So before you start, placing vias and making sure that the spacing is within a certain range, so that if it's too small, you're going to actually be paying more money for something that had a smaller spacing. Probably because it has to have a lot more care to it. So let's go ahead and get started. So the size of my board, so in inches. So if we go to, I'll show you the size of my board here. 782 mils. So that would be 0.782 mils, inches. And then for the length, I'll measure 2034 mils, which is going to be 2.033 inches, or 34 inches. And quantity, and I'll just keep the least amount. You need 2 layers. You need a bottom and a top layer for a transmission line. Material, FR4. They don't have aluminum substrate, as I said. They don't. So click this one here, TG 130 to 140. And my thickness, I want to show you my tech substrate here. So my substrate is 25 mils long for FR4 board, including the bottom and the top are both 1.4 mil. If we add those together, it's roughly about 28 mils. and about 28 mils to 28 mils to millimeters is 0.711. So that's going to be a thickness between 0.6 and 0.8. Pick that one. Minimum track spacing. So the minimum track spacing I have for this circuit is between here and here. You can also check other parts of your circuit. This is 8 mils here. This is probably the smallest, I'm not sure, but let me measure that. It's about 5.6 mils. So that is about the minimum track spacing, so about 5 mils there. Minimum hole size, that is the minimum, so my minimum is 10 mils for this drill here, and 10 mils to millimeters. I just remember it is 0.25 millimeters. You don't want any solder mask, you don't want any silk screen because that will affect the quality of your signal. Also, you don't want anything here. Surface finish, you don't want any surface finish. Via is not covered. That's what I put. So, finished copper, 1 ounce. So I do the smallest size. It's better to have smaller conductance for your design, actually, for an LNA. It's a rule of thumb I've heard. So 1 ounce copper to mils is you guys probably saw that before on here, about 1.4 mils there. And that's how I got that 1.4 mils for copper here and the copper on the bottom. So, and now you can add assembly service. So PCBWay will supply the parts for me, or you could do you will supply the parts for them. This way also you could try to solder it yourself and see, you know, basically you'll get the components also, whatever components they did not use for their manufacturing, and then they'll send you the rest of the stuff that they got, and then you can try to make it yourself and see if it has the same test results and everything. So board type, single pieces, assembly, top side is the only part that needs assembly. Quantity, I just put 1, just want 1 done. It's probably better if you have 2, because then what if one of them is like totally off? Something happened to the circuit, and you know, you may wonder if it was part of the manufacturing part of it, you know. So get 2 of them. Number of unique parts, that was 4. Number of SMT parts, 14, 0 for through hole, and then calculate. So you got about $142. You can always try to see if you can make it cheaper by trying to increase the size maybe of the hole size maybe, but I'm not sure if that will do that. now. You see, if you go really small with the hole size, it'll increase your price to like $100 more. And also track spacing has to be within a range so that you don't have to pay so much money. 142, so that's good. Now, after you do all that, you would save it, and then you would send them your Gerber files for the design. So let me show you how to get the Gerber files. So as I said, I'm not sure if I said this, but the PCBWay that I'm using as the manufacturer, so for example, like these vias here, I have here, they won't create a real drill file somehow. I think it's just like somehow it gets corrupted or something into the system. So in order to verify your design is correct for them, go to gerberviewercom here and then upload the file. So let's go ahead and we're going to put this circuit into Eagle. So I'll put this into LNA Gerber file. Okay. And now we're going to go to Eagle PCB Software. This way that I will be able to get the drill files that they need for the vias, and also not just that, they need an outline layer for your circuit too, which is actually just the size of the basically it's actually the same size as the bottom layer. So I don't know why they have such trouble with, if some things are off, they like to be ordered and make sure everything is correct, the same as every design for everyone else. You want to make sure that they get what they want. So we need to make an outline layer and create the drill files for them. So we'll go to, so you can go to new project, new, and then new board. Now we're going to import the Gerber file. So I put in an LNA Gerber file here. So I click cond. Alright, import that. So as you can see, it kind of created a weird looking mess there, and so basically now it'll be just too much work to make your the pads for the transistor again. So what you're gonna have to do in this case, it can actually generate from Advanced Design System for the top layer already, so I will put the top layer into the file instead. You'll see. Alright, let's just keep going here. And import the bottom layer. We call this bottom. Import. And then I'll put down the default for the drill files. It's not the actual drill files, but it'll be a reference for me. So drills, and then import. Alright, there you go. And now we need an outline layer. If you don't have that outline layer, they're gonna give you some trouble. So all you have to do is just make the outline the same size. Alright, in this case my grid is not fine, so we're going to have to go to grid here, finest, and then you can go anywhere with it. So this layer is a drill layer, but I'm going to change that in 1 second here. So go to info, click that, and then this will be dimensions. That's the dimension of your PCB, or basically the substrate. Apply, and now we need to make those vias. So as you can see, the vias are kind of big here. We'll make them the same size as what I have on this design. Just click there. So here I have, this is a via 1 pad stack 1. So as you can see here, it's 10 mils for the drill and 15 mils for the pad. So go to info there. So the diameter of the pad is 0.015. Drill is 10. And apply. So as you can see, something weird. The via is totally not the size that the drill's not as smaller than here, and and the pad is way bigger than the pad on here. So the reason for that is because we have to go to design rules, annular ring, and they have this thing where you can specify a range of your design, but it really just makes my designing more harder, because it's probably for people that are, that have a really big PCB design to go through, and then they accidentally did something. I guess it's to, keep people from doing accidents. So alright, now apply. As you can see, that made the pad the same size as here. And we can copy, put one there, and there. When you're doing it, you can be more detailed. But right now, I'm just going to do these vias right here, and I want to show you the difference between the file when the drill files were made for this drill file here, which didn't really generate anything. You'll see on the website here, online Gerber. So another thing I forgot to do, we need to specify what the dimension layer is. So you click new Gerber file. This one's going to be outline. Call it outline. And then you can use, so what I used was dimension. There's also, they also use milling. I guess that's for like if your board is different and you want to make it in a certain shape, I guess. So here there is a Gerber file name for the outline, and it's specific. I didn't know how to do this, and so if you go to PCBWay, they give you some helpful tips for your generating your drill files and stuff. So here they have different drill files that they require. It's either outline file, GKO file, or I think it's GMO file. I'm not too sure what the other one, but just copy this here, and as you can see, it says select layers 20 for dimension and 46 for milling, which is what I did. Paste, and then process the job, and then I will put this into outline layer. I already made a folder for it, so I'll just put it in there. I think it's the same. I'll have to replace the file anyway here. There you go. And now all we have to do is save that. And now we generate the Gerber file. We go to generate cam data, click OK, and then this will be called for YouTube tutorial. Alright, whatever. So save. Alright. We want to extract this. And now we can see our drill files and the Gerber files. So, as I said, the top copper, the Gerber file that was generated from Eagle is not going to be the same as what I generated from Advanced Design System. And that actually has the Gerber file from Advanced Design System is exactly the way the board is supposed to look. As I showed you from on Eagle, that this created a huge mess here, and that's what's going to look like on your design if you generate this. And if after I generated it, I got a bunch of, I would get this on using the gerberviewercom. So what we're going to do is get rid of the top. Alright, and the bottom can stay there. There's nothing that was changed there. So where did I go to get that? Export. So export this. Outline layer. let's just put this new folder in here. I probably did this already and I forgot where it is, but we'll call this ADS Gerber. Alright. ADS Gerber. So your cond is your top layer. So I'll put this here. I can rename it and call this top copper top. Okay, there you go. And now the layout, the outline layer. Where was the outline layer? ADS Gerber. Outline layer. Alright, there it is, this one. So put this here. Alright, great. I think we're rock and rolling now. The drill files, they're fine. I will show you the difference between, what I generated with the drill files that were generated from the ones that were put in from Advanced Design System, which won't come up, and you'll see. So for YouTube tutorial, now I'm going to send this to compressed zip folder, and then I'll show you the design. There. Alright, here's the drill file. So as you can see, we only have 6 drills. Everything else is not there. So you're gonna have to make those drills in Eagle, as I showed you. So here is the bottom. Here's the bottom layer, and here's the top layer, and there you go. The file looks good. But now for you, when you do the design, you're going to have to put those vias in each part of your design here. Replace them with the vias that were generated from Advanced Design System. So and then after that, take this file and give it to the PCBWay, and they should be ready to get your PCB manufactured. So I hope you like my video, and please subscribe. Thank you.